Good morning and welcome to Boston Outlook. I'm your host, Julee Marra. On the line with us this morning is Chris Carberry. He's the CEO of Explore Mars. Welcome back.
Well, thank you for having me on.
It's been a little while, but we all saw the news over the past week about Opportunity Rover, and I was like, wait a second, we haven't heard from Chris, so I need to get him back on for the update. So what's going on?
Well, very sad news, of course. The Opportunity Rover perished finally, but, we should put that into context. When Opportunity and Spirit, its twin rover, landed in early 2004, the mission planners were hoping, if we're lucky, we'll get 3 months out of them. And, of course, they weren't even sure. They thought it would be lucky if they landed one successfully. But within a 3-week period, they managed to land 2 of these rovers, and this comes at a very critical time in our space program back then. It was not long after the Columbia accident over the skies of Texas. It's also just a few years after NASA lost 2 Mars robotic probes back in 1999. So it was kind of at a low point. We were all trying to figure out what the new direction of the space program would be, since it had been after the Columbia accident. It had been determined they wanted to retire the shuttle, but they didn't know quite yet. So then comes, these twin rovers successfully landing, and it helped stimulate. It wasn't the only thing, but it helped stimulate a lot more excitement. And at that time, when George W. Bush was in office, they announced a vision for space exploration, which went through a lot of changes over the years. And, we still haven't gotten anywhere, but meaning sending humans beyond low Earth orbit. But it helped to generate excitement that we hadn't seen in a while. So I think the timing was very good. And if anybody had told them back then, or us, that one of these rovers would last for 15 years on the surface of Mars, I don't think they would have believed that. So it was a remarkable mission, not just for Opportunity, but even though Spirit died in 2010, that was still a very long and successful mission, much longer than they had anticipated. Yeah, as I said, even though they said about 3 months, they were hoping it would be longer, but certainly wouldn't have anticipated 15 years.
Yeah. So how is that setting the stage for what's going to happen next?
Well, right now, it's an interesting time. We're trying to figure out what direction we're going. And in some ways, the Curiosity, that's the other one. I'll get to that in a second. The Spirit and Opportunity rovers help set the stage for frankly, an unprecedented series of successes on Mars. Mars has been historically extremely challenging. Prior to our current run, it's been, most countries have not succeeded, and so it's like a graveyard of old robots that never succeeded on Mars. So, but since then, we've had, Spirit and Opportunity. We had the Curiosity rover. We've had, landers like the Phoenix lander. Most recently, the InSight lander. And then, of course, we have in 2020, just the United States, the Mars 2020 rover coming up, which is essentially a twin of the Curiosity rover, which landed in 2012. But that is the end of our currently planned robotic missions, and we see that as a problem. There's a lot of excitement right now about sending humans back to the moon and on to Mars, and that's great. We're very excited about the national enthusiasm and the political enthusiasm for that. But I think people tend to think that, now that we're thinking about sending humans, we don't need to send robots.
Yeah.
And that's a mistake, because if we're planning on sending humans in the 2030s to Mars, the 2020s are very important. So we're hoping, that lesson of Curiosity, I keep mixing up the name, Opportunity, as well as Curiosity, which continues to rove Mars, will help to show that these robotic missions are important, and there's still more information we need on the surface of Mars before we send humans there. So we hope we'll be able to generate excitement about continued robotic missions in the 2020s to enable human missions in the 2030s.
Right. And as a human, right, it's a pretty big risk to just go to Mars. And I mean, if you don't know kind of the whole big picture of what to expect, I mean, how does it make sense that we just jump to sending people instead of the robots?
Well, we can't. It's not just a matter of sending robots. There's a lot of mission design needed to send people to Mars. And, we've been arguing about it. Well, we've been arguing about it endlessly for decades. Which is better? Should we go directly there? Should we stop places in between? What's the level of safety that we need? And since we are always fighting over destination, where we go first, how safe should we make it? We never get anything done. And so at some point, I'm hoping soon we can just make a decision and get it done and start designing these systems. Because as you mentioned, we can't just go straight there. We have to make sure we have systems that can do it. Basically, if you're sending humans to Mars, you're probably committing them to 3 years away from Earth. Because it takes about 6 to 8 months there, 6 to 8 months back, and generally most mission plans would call for them being on the surface of Mars for about a year and a half. And so that's a long time away, and you need to be able to have systems that are going to keep your crew alive reliably, life support systems, and making sure you know how, and other things like landing on Mars. While we've landed robotic probes on Mars, the biggest thing humanity's landed on Mars is the Curiosity rover back in 2012, which was 1 metric ton. If we want to send humans, though, we're going to, at minimum, we're going to have to land 20 at a time, probably more like 30 or 40 at a time, and that will be trying to land multiple pieces as well. So we haven't quite figured that out. There are a lot of ideas out there, but we have to really start development on that to make sure we can make it work. Because we obviously don't want to get them all the way there and haven't thought through the landing, on Mars. Elon Musk has a famous joke that he wants to retire on Mars, but preferably not on impact. Well, that goes for anybody. Nobody wants to land on Mars on impact. So, but once you're there, you also want to, most people aren't going to want to retire on Mars. They'll also want to come back. So you also have to figure out those systems for getting off the surface and getting your crew safely back to Earth as well. So a lot going on, a lot of really interesting thinking going on. So there are some great plans in development, but once again, decisions have to be made, and we have to be able to accept risk. We're never going to make this 100% safe. It's always going to be very dangerous, but it's worth it. And people will line up to be on these missions to be able to be the first to start exploring, another planet.
Yeah, and I mean, I feel like, too, because all of this work is being done remotely from Earth, it's like you can't troubleshoot necessarily as you would if you were right there.
No, absolutely not. I mean, the robots have been extremely successful, but, by human standards, they have been extremely slow. Yet, of course, there's a time delay because of the distance to Mars. So this always takes a long time for the signal to get there and back. They never want the rovers to go too far ahead. Don't give them too much autonomy. And then, they're very slow. They also, right now, they don't, for instance, one of the things we want to do is get below the surface of Mars. Look, dig down. Until very recently, right now the rovers have had these little scoopers or these little drilling devices to get down just like millimeters, or the Phoenix lander scooped down a little deeper, but it was still like inches at best. And right now, we just landed the InSight lander not earlier this year, it's now last year, And, that's going to drill down a couple of meters, but that's a major engineering challenge. Basically, one human with a shovel, with one scoop, it would be able to get further down in the Martian surface than all of our robots have succeeded ever. I mean, as I said, Phoenix will get much deeper this year, But until now, one human with a shovel could go down instantaneously further than we've ever gone to start seeing what's below the surface.
Right.
And that's important because, we're trying to determine whether there has been life on Mars or if there still is life on Mars. And most scientists believe if there's life on Mars, and I'm talking microbial life, it would be below the surface, away from the radiation. And there's also strong evidence of frozen but also potentially liquid water below the surface of Mars. And for instance, ESA, European Space Agency, announced the discovery of a subsurface liquid lake on Mars last year. That was very exciting. We had, there were lots of speculation. Most people assumed there was liquid water below the surface, but this was the first time it was verified. And so, but when you have liquid water below the surface, that greatly increases the chances of life. Where you have water on Earth, everywhere there's water on Earth, there is life, particularly liquid water. So that's why we want to get below the surface to see, once you get below those top layers that are constantly being exposed to radiation and other nasty stuff, is there evidence of past or present life, as well as how easily accessible is the water? Because if we're sending humans there, we ever want them to be sustainable human settlement on Mars, we need to be able to utilize the resources, specifically the water.
Right, and because if you're sending them, you said that there's like kind of that weight restriction when you send humans to Mars. You can't be shipping them with water and all this sorts of food. Like they need to be able to sustain, as you said.
Yeah, not if you want them to stay there sustainably.
Right.
For the first missions, we're going to have to do that. Well, there are some people who want to use in situ resource utilization, essentially living off the land on the first missions. It's probably more practical on those initial missions to send everything they need and, practice with utilizing resources, but don't be dependent on it.
Right.
But you can't, if you want sustainability, you're just not going to be able to do that. You can't ship it all every time. It's like when European settlers were coming to the New World, they were relying on ships from Europe for all of their supplies, all their food, all their beer, all their water. It would not be a sustainable situation.
Right.
So even more so with Mars, since it's much further away, it's much more challenging. So to be able to, if we have any hope of being able to have any sort of long-term occupation of Mars or anywhere else, we're going to have to be able to utilize the resources as well as learn how to grow stuff on Mars, agriculture. And there's a lot of research into that as well. Can we grow crops in the Martian soil? Not out in the open. It would be within artificial atmosphere under domes or in greenhouses, but can we actually grow crops in the Martian soil? And there's actually a lot of work being done on this, not just for Mars, but also in microgravity. So all of this, there's a lot of interesting projects going on to look at all of these problems.
I want to ask you too, though. I mean, so even if there is water and it, is enough to sustain life on Mars, like, I'm not even sure how I want to ask the question, because it's like, part of me wants to say like the safety of the water, but then also like how would humans respond to the resources that are on Mars? Like, would there maybe be some sort of like a speed bump type of a reaction, like where maybe humans don't necessarily respond to the water on Mars the same way they do here on Earth? Does that make sense?
Well, it does. It's either whether they're contaminants or actually the biggest question, and it's one of the biggest questions out there right now. Now that it looks like we really are going to go, the question of planetary protection. And that means planetary protection, there are two parts to it. Protecting, if there's, for instance, life on Mars, ethically, what can we do? First off, we don't want to infect it with our own microbes. Humans are big bags of microbes. So when humans go, we're going to be bringing a lot more microbes, at least Earth microbes that have ever been on Mars. And so we don't want to contaminate it, at least before we understand if there is indigenous life. But, but there's a lot of discussions on, what's our responsibilities to life on Mars. And, there's also backward contamination. Can we bring some of that life back to Earth? Could that be dangerous to the astronauts or Earth? Not just like some horrendous pathogen like in a science fiction movie, but, similar to an invasive species or something, whereas it doesn't destroy life, but it also changes it, like any other invasive species. So a lot of discussions here, and one of the big issues right now is, can we, the places that we want to send humans are also the places that are most likely to have life. So there are big debates, for instance, where the resources are, where there's water. And so there's big debates going on regarding what the protocol should be. And I think the general consensus right now is, yes, we want to send the humans, but we also don't want to completely contaminate the planet. So they're taking a look at the example of, for instance, Antarctica, where there are specific regions where humans go, and yes, there's an accepted level of contamination just because you can't avoid that with people. But then there are other protected areas so that we can, get our science done, learn if we can live off the land, also discover ourselves if there's life there, but we're also not completely contaminating the entire planet, at least at the beginning. Who's to say when commercial activity goes, rules and laws and regulations will develop as we go. But right now we are looking at how to account for the protocols for the initial human missions to Mars.
I'm just thinking, like how sometimes when you go to the doctor, they say, any travel out of the country. Maybe someday there'll be a question that says, any travel out of the planet.
I hope so. I mean, it would be a real shame if that wasn't an eventual question. So, and there's a lot of activity here, not just Mars, but of course, all these commercial companies that have been working ceaselessly for a while, like SpaceX, Blue Origin, or Virgin Galactic, and there are a bunch of others. Bigelow Aerospace, who wants to build space hotels. So there has been slow but steady progress. All of them have learned this is not easy. It's much harder than most of them originally thought, but that's fine. They've still been making great progress, and I'm hoping we're finally there. And so it's looking like a lot of these companies are finally at that point. For instance, with NASA hired some companies to build replacements, basically to bring, on American spaceships, to bring Americans back into space. For the last several years, since the retirement of the space shuttle, we have been, of course, paying for space on the Russian spacecraft. And but of course, there's great desire to make sure we can get ourselves into space, not be reliant on another country, particularly a country where, let's just say, it's been complicated, a complicated relationship over the last few years. And so this year it looks like we might finally have the first test flights, hopefully human test flights, of these two vehicles that SpaceX and Boeing have created. And, of course, they've already, companies like SpaceX and Northrop Grumman, formerly Orbital ATK, were doing commercial crew. So they've already been privately, through these companies, sending supply ships up to the International Space Station. Now we're hoping to make the jump to being able to send humans. But then, of course, it looks like companies like Virgin Galactic and Blue Origin might be able to start sending that, paid tourists up to suborbit sometime this year or next based on their progress. So hopefully these things will all move forward. We've heard it before, unfortunately, because there's been a lot of excitement and then, something happens, sometimes something's tragic. We hope that doesn't happen, at least right now, and that we can finally make this jump to enable commercial activity, so people can pay their way into space more regularly than they have in the past, and for a cheaper price. And when I say cheap, I mean at this point, most of the starting prices around $200,000 to $250,000 for these short, 15-minute flights in space. or actually shorter technically in space, but it's a start. And, of course, when, for instance, the previous space tourism, and there has been space tourism a number of years back with Dennis Tito or Richard Garriott or other people, or Greg Olson paid over $20 million to go up to the space station. Yeah, that was great. It was great for them to start that process, but that wasn't something that was necessarily enabling the masses to go into space.
We're chatting with Chris Carberry. He is the CEO of Explore Mars. And earlier you were talking about how the 2020s, that decade is really going to be, I want to call it crunch time. So do you feel the pressure?
Absolutely. Once again, we need to make decisions. 2020s, there's a lot of momentum, and this is great because this is one of the very few areas where there's bipartisan support. As you can, no matter where you stand on the political spectrum, I think everybody can agree there are very, very, very few topics that have strong bipartisan support as well as strong public support as well, which also makes me wonder why we don't make quicker progress on it as well when you have this level of support. But based on that, I'm hoping we can make a decision and decide what we're doing first. We're going to have to, once again, as I mentioned earlier, continue robotic programs to Mars. But if we're going to be utilizing the moon, we have to decide in what way we're doing that. Are we going to the surface? If so, is that going to be government-run or is that going to be commercial? There have been some announcements lately. I know there's a great desire to have, as well as for my group, to have that as commercially achieved in a manner as much as possible commercially, so it doesn't distract NASA from going further into deep space. But regardless, we need to make those decisions and start working on the systems. Because I mentioned there are some systems that are going to take longer than others, like landing on Mars successfully. It's called entry, descent, and landing. And we ran a workshop with folks in the space community, NASA, mission architecture, engineers, et cetera, looking at these technologies that we need to start now, and that one particularly had the longest lead time. It was, a lot of people thought it would take over 10 years. Some thought probably quicker, but we can't wait until we're at Mars and then realize, we're orbiting around Mars. Now it's going to take another 10 to 15 years to figure out how to land. That's not the best way of going about things. So, yeah, it is crunch time. If we have any hope of landing on Mars in the 2030s, we have to start working on these systems now. And if possible, figure out ways that overlap with lunar exploration as well. So, as you know, things as administrations change, sometimes the priorities change, and sometimes we have managed to just start from scratch again. But we want to do things in a way. I think most people agree that even if there's a shift in policy, we don't have to start from scratch. We're working on systems that, have benefits to both the moon and Mars and other destinations, so we can just get something done. Because I think right now, within the space community, there's a general consensus that we don't want to find ourselves in another 20 years being exactly the same place because we've been arguing so much. We couldn't decide on what we want to do, and therefore we did nothing.
Right, exactly. So the other question, too, I wanted to ask was, you mentioned about the European equivalent of NASA. Do you work in conjunction with them? Yeah. No, we work with, it's called ESA, the European Space Agency. And they participate in our workshops, not as in our conferences, not as much the level we would like them to participate in, but we're going to be trying to work more and more with Europe and other nations and other space agencies over the upcoming years also. But they have participated in this, and there's been some hesitation, not just with ESA, but other space agencies, questioning whether the United States will stick with its plan. Like for the previous years, everything was gung-ho, we wanted to go to Mars, but there was skepticism whether we would stick with that. And now we still say Mars, but now there's more of a lunar focus. But I think that's actually made the Europeans and others more excited because they realize they want, at least from conversations I had, it's a shorter term goal and they see that it's more likely to succeed. So
our goal is to try to build consensus, find the right way ahead, finding ways to work with our international partners to be able to, well, yes, enable to go back to the moon, but without delaying Mars by that much. So we can go to the moon one way or another, but still get to Mars in the 2030s. And, that's tricky because, it's not easy. NASA gets a very small percentage of the budget. And so you have to find the right way of doing it, the right way of utilizing new commercial entities, international partnerships, and just finding efficient ways of doing things, which is not always necessarily the fallback position for big government organizations.
Right. So we have a couple minutes left. So I'm thinking the Humans to Mars Summit is coming up in May, which is like a big, big weekend for you. Do you want to talk a little bit about that?
That's actually weekday. It's a Tuesday.
Oh, is it really? Oh, well, then it's a big, middle of the week. Yeah, celebration.
Yeah, no, we do it in the middle of the week. Because we have a lot of space professionals there, and so everybody, the space professionals at least, prefer being there during the work week. I do too as well.
Can't blame them.
Like having the weekends not at work. So regardless, yes, it'll be May 14th through 16th this year at the National Academy of Sciences building in Washington, D.C., and, once again, this is one of the big themes will be, how to integrate the moon and Mars, how to integrate the international partnerships and look at some of the remarkable science that's being done, but also looking at STEM education, how important that is, and, seeing if we can integrate all these parts, of our culture into this to see how that can keep the momentum going, because it's not just building the rockets or the science. It is just bringing the rest of society with us, showing that there is a part to be played by everybody, as well, students, people within the communities. People don't realize there's a lot of work being done on the space program in places you wouldn't think. If you look at a map of where money is being spent for NASA programs or indirectly through some of the contractors, there are very few places in the country where you don't find some small company, a small business, helping to enable humans to go to Mars or other places in space, places you would never have dreamed of. You always think of Boeing, Lockheed, or SpaceX, but there are just thousands of small companies around the country that are doing important work to enable this, but people are not aware of that. So one of the things we like to do is highlight this, how it affects the economy, STEM education, and how we can build these partnerships to make this happen.
So is the summit open to the public, like with the ticket?
It is. Anybody can come. There were while we do have a lot of technical talks, we also have a lot of talks that are specifically focused on the general public. And so we always have high-level folks at NASA. For instance, we always have the NASA administrator. The administrator right now is Jim Bridenstine, and he'll be speaking. We also have, we usually have people from the entertainment industry, mission scientists and mission architecture people. We also have people who talk about technology and innovation. We always have people who talk about virtual reality and augmented reality and space exploration and things like that. Another thing, like we're going to have a special session on feeding Mars. As I mentioned earlier, we're going to have to learn how to grow food.
Right.
So one of the topics will be, will Martians be vegan? And since it's not going to be practical to have cows on Mars anytime soon, and so will it be practical to have meat? And so, we'll grow food, but there's also a growing industry of, for instance, lab-grown meat. And, you can just bring a few cells, and you can have an endless supply of meat. And would that still be considered, does that count, within the world of vegetarianism or veganism? If you don't kill an animal, where does that fall in the ethical scale? And so we'll be having that discussion on what the options are for growing food, and will there be meat, and how will that meat be produced if we have it? And so it's an interesting discussion.
And you know what? I feel like this conversation really doesn't end here. It will continue. Unfortunately, we are out of time, Chris. So before I let you go, any quick closing thoughts?
No, I think it's just if people pay attention, this should be an interesting few years. Yeah, a lot of cool things happening. We'll have those commercial crew vehicles hopefully launching this year. We have the Curiosity, not the Curiosity, it's Twin, the 2020 rover launching next year, but there are also other countries launching. The next year, it's a big year for international Mars missions. The United Arab Emirates launching a probe to Mars. Europe sending another one. There are others. So a lot of exciting things are happening, but we also have to make those key decisions. If we're going to get something done, we have to decide. So hopefully the next couple of years, we will finally make these decisions and finally get moving.
And I feel like we get the firsthand update here on Boston Outlook. Always a pleasure to talk to you, Chris Carberry, the CEO of Explore Mars. More information at ExploreMars.org. Thanks so much for your time this morning.
Thank you again. Always good to come on.